Good day everyone and welcome to Asia Conference on Multidisciplinary Research. I am Ron Costa, a BS Medical Technology student, together with my co-presenter Mayara Laline Abiog, and we're here to share our research which is entitled In Vitro Activity of Silver Ion Derived from Perna viridis, also known as green mussel shell, against extended spectrum Beta-Lactamase producing Klebsiella pneumoniae. So let me start with the background of the study. We Filipinos love to eat. It is a huge part of the culture, community, and celebration that we much enjoy by sharing with anyone that are willing to partake. One of the food that we love are seafoods, which is a nutrient-rich food that is a good source of protein, vitamins, and minerals. So this is why we do research about green mussel shell, also known as Perna viridis. It is a bivalve mollusk that belongs to the family Musselidae. It is economically important in several countries including Philippines, where it is harvested as food due to its fastidious growth. However, it generates a large amount of waste. Shell waste recycling can be a good thing as an alternative to disposal, in terms of disposing the environmental problem and yielding economic benefit. This research into further application of mussel shells are conducted, stated by Meili et al. At 2014. The immune system is made up of antibodies, white blood cells, and other chemicals and proteins that fight and abolish foreign substances such as bacteria, infections, and viruses that they recognize as unfamiliar and a threat to the body's overall health. The immune system works together to reduce these microbes from entering the body and preventing them from growing and causing illness. Silver is a natural mineral that can supercharge your immune system and help you stay healthy.
For the methodology, this study will utilize experimental research design. Experimentation involves procedures in order to determine the concentration of silver ion designed from green mussel shell that will inhibit the extended spectrum beta-lactamase producing Klebsiella pneumoniae. For the antibacterial material preparation, collected raw mussel of Perna viridis from the coastal areas of Cavite was firstly washed, removing the residual meat and attachments, and then coarsely ground. The ground sample was immersed in sodium hydroxide solution for 24 hours to remove the stratum corneum. Thereafter, it was dried overnight at 100 degrees Celsius and finally ground using a pulp mill. The pre-treated mussel shell was dispersed in 0.1 molar silver nitrate solution with a weight over volume ratio of 1:10. Sodium hydroxide and silver nitrate were of analytical grade. The pH value of the mixture was adjusted to 6.5 under continuous stirring for 4 hours. For the silver release in prepared antibacterial material, the material was obtained by filtration, washed with ionized water, and dried in the oven for an hour. Sterile phosphate buffered saline were used to dilute green mussel shell for it to release silver. A volume of 2 ml PBS are used in different milligrams of green mussel shell powder, gentamicin, and co-amoxiclav to make different concentrations that will be used. It was shaken and left for 24 hours. For the determination of minimum inhibitory concentration, or MIC, and minimum bactericidal concentration, or MBC. The MIC was determined in brain heart infusion broth using twofold dilution of prepared concentration of silver ion, gentamicin, and co-amoxiclav in 5 tubes. The culture was adjusted to 0.5 standard using densitometer. 500 microliters of prepared dilutions was added in 2 ml of BHI broth, then diluted to a series of tubes. Each tube was added and inoculated with 10 microliters of culture of ESBL Klebsiella pneumoniae. Tubes were incubated at 37 degrees Celsius for 24 hours, and for the determination of MIC, tubes were examined using tube dilution method as the lowest concentration that will demonstrate no growth or absence of turbidity, and plated after to confirm its susceptibility. For the determination of MBC, an aliquot of 25 microliters from all tubes in which no visible bacterial growth were observed were seeded on Mueller-Hinton agar plates and were incubated for 24 hours at 37 degrees Celsius. The MBC demonstrates the lowest level of antimicrobial agent, resulting in no microbial death and no growth in the culture media after incubation. The entire test was carried out in triplicates. For the objectives, objective number 1 is to determine the spectra of green mussel shell when analyzed using Fourier transform infrared spectroscopy or FTIR. Objective number 2, to determine the minimum inhibitory concentration or MIC of silver ion isolated from green mussel shell, amoxicillin clavulanic acid, and gentamicin against ESBL Klebsiella pneumoniae. Objective number 3, to determine the minimum bactericidal concentration or MBC of silver ion isolated from green mussel shell, amoxicillin clavulanic acid, and gentamicin in killing ESBL Klebsiella pneumoniae. For the results and discussion of objective number 1, that is to determine the spectra of green mussel shell when analyzed using FTIR. The silver carbonate phase resulted from the reaction of carbonate ion slightly dissolved from mussel shell and silver ion in silver nitrate solution. Its occurrence confirmed the successful loading of silver onto the raw shell waste of Perna viridis. There was no significant difference between the FTIR spectra of green mussel shell from Mealy et al. Of 2014 and from the results isolated by the researchers. The infrared absorption spectrum of the antibacterial material in the study exhibits the same wavelengths of Mealy. For the objective number 2 and 3, to determine the MIC and MBC of silver ion isolated from green mussel shell, amoxicillin clavulanic acid, and gentamicin against ESBL Klebsiella pneumoniae. The table indicates the MIC and MBC of the treatments that are used in the study. Silver ion, the antibacterial material that is extracted from the green mussel shell, shows a good MIC and MBC of 0.125 mg per ml. Gentamicin, the negative control, displays a low MIC and MBC of 5 mg per ml, while amoxicillin clavulanic acid with a high MIC and MBC of greater than 2.5 and 0.36 mg per ml due to its bactericidal effect. The figure shows the growth inhibition of ESBL Klebsiella pneumoniae in three treatments. Green mussel shell demonstrates a good antibacterial activity that is due to the silver ion loaded with a dilution of 1:16, very similar to the present study of Mealy et al. Wherein tube number 4 shows no growth when plated, while tube number 5 becomes turbid after incubating for 24 hours and demonstrates some growth when plated. Highest activity was found with the positive control amoxicillin clavulanic acid with the dilution of 1:32 and lowest activity of 1:8 dilution from the gentamicin.
For conclusion and recommendation of objective number 1, we conclude that successful loading of silver ion from the shell of green mussel shell is acquired. We recommend other species might be a potential biomarker for other heavy metal, and also instead of shell, we researchers suggest to use its meat as it may contain heavy metal. For 2 and 3, in summary, the MIC and MBC results of the silver ion are comparable to the standard antibiotic gentamicin and co-amoxiclav. We conclude that the result indicates that the silver ion was able to inhibit the growth of ESBL Klebsiella pneumoniae with an MIC and MBC of 0.125 mg per ml. We recommend the use of other tests and methods for further confirmation. For the impacts, this research has proved that silver ion could be synthesized from green mussel shell and also exhibits antibacterial property This could now serve as a basis for future studies concerning microbiology. Insights: green mussel shells could now be utilized by producing viable substance like silver ion. Green mussel shell or Perna viridis have a good antibacterial activity in addressing the preponderance of multi-drug resistant bacteria such as ESBL Klebsiella pneumoniae and have a potential for medical applications. That's all. Thank you and God bless.